Yeah.
So.
Yep.
So
You're up.
let's go. So welcome back to the Ceph Developer Monthly. This is the meeting for April 2018. And we have some topics to discuss today. We're going to start by some usability discussions that Danny, Sage, and the rest of the guys started during CephaloCon in Beijing. So, showtime, guys.
Okay. Yeah. So indeed, yeah. Danny Algraf from Deutsche Telekom and I started chatting at CephaloCon and ended up having some somehow useful discussions about small sort of paper cuts that could help usability a bit. And we noted these down. I go through them. The link is there in the chat. And these are in kind of no particular order, and some of them are probably bad ideas, and maybe some are some good ideas, but we can discuss. Okay, first one was about basically it's Ceph auth edit. So the problem here is that Ceph auth caps subcommand is very simple to make typos and break client key rings. So we thought of a Ceph auth edit command that would just pop up your editor interactively, pop up a Vim, lets you edit the caps, and then save it, and it would write the caps. Very simple. Maybe this is useful, maybe not. What do you guys think?
It seems like it's an improvement over like dumping them and cut and pasting them onto the command line and then editing them to put them back in. But I think that the bigger goal would be that we don't normally have to edit the caps at all. That most of the time you'd be like, there's a new Cephfs command for Grant. I can't remember what it actually is, where it just does it all for you. So I don't want to lose track of like that larger goal. If there's ever a case where you're actually manually editing the caps, we should try to like avoid that.
Right.
But that being the case, there are always going to be obscure cases where you are editing the caps. So maybe
all of the existing caps that we have, for example, if you add RBD pools or something like this, you have to update the caps.
What do you think, Josh? We've already added some like random special bits in the Ceph CLI.
Yeah, I mean, it seems like a reasonable addition just to get like verification that you're like maybe similar to Visudo, where it verifies that the syntax is correct and the caps don't just make complete nonsense, at least. It's really a small addition, so I think it's useful.
We can make a card for it somewhere.
I mean, as I'm speaking, it sort of goes with the next +2. I mean, if some interactivity to caps editing, just general interactivity caps editing would be helpful, I think. Like maybe when you run Ceph auth caps, it could say, "Oh, hey, looks like this is your diff. This is what you're changing. You're adding this, or you're removing the R permission from the mon. Do you really want to do that?"
Mm-hmm. Yeah. Okay.
The CLI doesn't currently understand the caps, right? It doesn't like instantiate MDS auth caps to validate things.
No, it does no validation at all, but the monitors do now, right?
I believe the monitors do. So if you try to inject caps that just don't parse, then you'll get an error.
That's new. Okay. I don't think it's in Luminous, so people haven't seen it yet.
Okay. It's a mimic thing.
Yeah. Or maybe we backported it, but I don't think so, and not in a release yet. But more generally, do we actually want to encourage people to do that sort of diff style editing on the command line, or is the dashboard our answer to that question?
Yeah, I was wondering about that. Having a UI for that? might help.
Yeah.
Pull requests are welcome.
I mean, Dan, that's partly a question for you. If that's in the dashboard, is that just not okay for you guys, or?
Yeah, I'm not sure. I'm not sure.
Okay.
I mean, I guess I'd like to use the dashboard. But I don't know. I mean, is the dashboard? Yeah, the dashboard will do more than the CLI. The dashboard will do this higher level stuff. I mean, I like to think that you can do everything with the CLI
Yeah.
that you can do with the dashboard. I hate
Well,
to be
this isn't adding functionality to the CLI, right? This is just making it easy to edit. It's just like cut and pasting the old value into your command line so you can edit it before you run the command. At the end of the day, the CLI, you're going to edit the file, and it's just going to do them on the same on command that you could have typed.
kind of like export to a file, open it in the editor, then import it.
Right. Yeah. This is just the porcelain or whatever you want to call it.
I mean, one thing is I'd hate, like in any kind of weird crisis situation, you know, I'm home on the weekend and there's some issue. I'd hate to have to like use the Microsoft remote desktop to get into the CERN firewall and spin up a web browser to change something, right? That's why I like CLI to be able to do everything.
Yeah.
I don't know. Okay, that's probably. There's a +1 there, so I don't know. Okay.
Yeah.
Should I move on?
Yep.
Okay. The next one was that the Ceph CLI could use like a normal and expert mode, and like a you know, I don't know. Danny had some funny video game descriptions of like a death mode or something for the very advanced options, but basically you would hide some of the subcommands of the Ceph CLI unless you enable an expert mode. And this is like taking inspiration for lots of like filer appliances do this. They don't enable. They enable. You have to enable admin mode on a NetApp, for example, if you want to see if you want to play with the waffle layout or whatever. I think we already have advanced, and we have different like difficulty levels for the config options. I noticed. I don't know where those are exposed, if anywhere, but we could add something like that to the CLI subcommands as well. Thoughts?
Yeah, it sounds like a great idea to me. I mean, we have like a million commands, and most of them aren't really that useful for what you're doing most of the time. So I think it makes sense to hide those.
Yep. And it kind of seems like bonus points if they fall into the same categories as the config options, where it's basic, advanced, and dev. Mm-hmm. I think were the categories that we did.
Would we call sort of non-advanced but data destroying commands like removing a pool advanced, or would we call them normal?
That's a good question.
Nightmare mode.
You get, I mean, just like with the health warnings, you get different opinions on different things, and the first proposal would be iterative until something is like, you know, it would take a few releases until most people are happy.
I think I like the idea of having the set of normal commands that are for sort of logical management of the cluster, like creating, you know, doing auth caps and pools, you know, the stuff that's really using the cluster rather than tweaking it. And maybe those would also be, I'm skipping ahead slightly in the Etherpad, but those would also be the types of commands that would have the friendlier interactive type behavior. But I think it's going to be harder to divide these things up into normal and expert than it was with the config options, because with the config options, almost all of them are in principle optional. You never really need any of them. Whereas with the command line stuff, like you've got real functionality there that you're sort of turning off if you hide something in expert mode, like, I don't know, creating custom EC profiles is probably expert. But at the same time, it is a first-class feature. We probably do want it to be friendly. So I think it's going to be really hard to draw that line.
Well,
Yeah,
it could be
and
that we
also-
have. Go ahead.
There's also the point. There's also that, things that are irreversible, things that can irreversibly make you lose data, like deleting a pool, you probably want to enable some mode, right?
Like
But that's
just-
that's not expert. That's not like beginner and
Yeah.
expert. It's like, I just want to enable data loss mode.
danger zone. Something.
Danger zone.
Yeah,
I
because
would
like
see-
pool delete is a normal life cycle basic thing that you'd want to do, not necessarily expert thing. Anyway,
Yeah.
yeah.
It seems like some of this stuff, though, we can hide in the expert mode if it's enabled through the dashboard. Like, we don't need to enable people to manually create erasure code settings if they can do it in the dashboard and have it be checked and a lot more friendly.
And if
But
there's
I think you run into a contradiction there, though, right? That we're taking the slightly more obscure functionality, making the investment to expose that graphically, right? Rather than having the graphical interface provide the sort of mainstream normal user stuff, and relegating the advanced stuff to the slightly more obscure command line, right? So like my instinct would be the opposite to what you just said, Greg, that the erasure coding, like creating custom erasure code profiles, is a somewhat advanced, albeit supported thing that maybe someone would fall back to the command line for. But I'm not saying I'm right and you're wrong. I'm just saying there's like it's like every one of these features is going to have a similar sort of conflict.
Yeah.
I think I would do it slightly differently, where I would actually, if we decided that custom erasure code profiles are complicated, then we would create a new command that's an interactive, guided, helpful version, kind of like this next bullet point, that like helps you choose a sane erasure code format and fills in the blanks. And that would be the basic version, and then the one that like lets you specify an arbitrary profile key value map pair or whatever would be the advanced one. And that would be sort of the analog in the dashboard. Like there'd be a wizard that would guide you through setting up erasure coding that like makes it really easy and understandable without having somebody actually like type in k equals 4 space m equals whatever it is.
To add my 2 cents, the only thing I hope is that we don't break any kind of command line stuff that would hurt third parties. So like CBT would be really nice for me personally if I could not have the creation of erasure code pool file.
Yeah, I think
profiles break.
this should, if you enable expert mode, this shouldn't change any behavior. It would add maybe some newer commands, but it wouldn't break anything.
You can have an environment variable like Ceph testing or something. Like you just set this and it just sets you in God mode right away with no extra switches needed.
Yeah. And then there'd be like a Ceph expert enable or something like that, or
It'd be really swell too if God mode also disabled all kinds of like warnings that are super irritating, like number of PGs and number of PGs per OSD and that kind of stuff.
I don't think that one, because we're going to need God mode for Teuthology, but we don't want to lose the warnings. Sorry.
There's something above God mode?
Okay.
Well, so let's move on. What about the idea of interactive commands that are sort of like prompting and guiding?
Right. So this was the next point, that like well, what example? Interactive prompts. Okay, and the CLI could be interactive instead of taking it's very as an operator, it's very difficult to know what the different options are. Like the documentation is even not always clear. Like when you're creating a pool, where does the erasure bit go? Where does the crush rule set go? Like this is all, placing these things in the right order is always tricky. So interactive pool create, interactive. What were the other examples that we thought of? So actually the cool example that we thought of was delete because so instead of saying like, yes, I really, really mean it, and having to like inject to the mons that, yeah, you enable delete mode, you would just try to delete a pool and it would say, hey, this pool has got this much data in it. You're going to remove all that data. And by the way, here's some ongoing IO and in this pool. Are you sure? Yes, no. And, then it would delete. So I can't remember who we were chatting with that the CLI, it's difficult to make the CLI interactive right now, but anyway, I guess anything's possible in software.
I think it was Joao you had mentioned. It's true
Yeah,
that
right.
the normal behavior of the CLI is sort of non-interactive. It just sends a command and gets a response. But we've already started kludging bits into the CLI for other stuff, and so I think it's totally feasible to add interactive commands. The code for them and logic for them would live in the CLI on the client side.
Yeah.
Just like
I
not
mean,
the
it's a
most
bit like
elegant thing in the world, but it's
Do we have any models for that yet?
We should get more into that, right? Because it's true that adding interactive stuff by kludging it into the CLI client is straightforward, if a little ugly. But if you get into things like prompting people for, I don't know, pool creation and having logic for informing them about, I don't know, the number of PGs or what the effective raw consumption of a pool will be if you pick a particular erasure code profile, you're very rapidly getting into a position where what lives on the client side would end up looking a lot like a manager module, right? So I think if we were going down this path, it would probably be better to find a way to have more of that logic be server-side, just be exactly the same logic that is going to also be presented in the dashboard when it comes to the sort of heuristics and whatever that we're presenting to people. So let's not overestimate how much we can get done by kludging it into the client.
Oh, I see.
Yeah, and I think it's important we don't, like right now, anything like this needs to live in the monitor, and it's important we don't do that. And that's part of, John, why I was suggesting that the more complicated features, if we can put them in the manager, it would be better. Maybe I'm just throwing it over the wall, but it seems like it's a lot easier to add safety through that sort of interactive workflow, and we know how to put that in the manager. And I mean, it's not that we couldn't, but we don't have a good way to put it in the CLI. And I don't think we have a good model for using the same code between both.
Yeah, I completely agree that the manager is the right place to dump this kind of stuff. I mean, if we have a lot of commands like this, we could even consider whether the interface between the CLI client and the manager should, be like a streaming thing rather than a call and response. If we really are doing a lot of interactive stuff, but the more stuff we add here, the more it makes me wish we were spending that effort on putting in the dashboard rather than having ever more elaborate CLIs.
I think it would be cool if you do it in a way that it can be a CLI or in the dashboard, like the same interactive prompts.
Yeah. So there is this other software-defined storage project that recently redid their CLI and has a manager, and the way they redid their CLI was by making it call out to their manager server that serves as the backend for their dashboard. That makes me cry, but probably just because I'm a C++ junkie. And I hate web APIs.
I think the problem is that the examples that we've thought of so far, pool create, pool delete, are like trivial to just kludge into the CLI. So I think you need an example where where you need.
Well, it seems like it's maybe the pool create is one, because like once you decide that it's going to be an erasure coded pool, then you have to decide what the K and M are, and maybe that depends on some other state. Or when you're doing delete, you want to like check whether once you know that what the pool name is, then you want to check whether it's empty or not, and then you want to check whether because it's sort of an interactive flow, it might be sufficient to sort of force us into a model.
Actually, pool create. I just realized pool create's going to be difficult because you can't make your heuristic has to your heuristic will have a different. The trivial heuristic would have a different outcome for the first pool you'll create versus the 10th pool you create. It has to know how many pools you're going to create.
Yeah, I think this is an area where the pull create is related to a low level of a command. We really want to ask the user like,
create an RGW.
create an RGW, create an RBD, create an SFFS instance, and all the pulls associated with that.
So I have like a mere complet that I have cool set tied out
so
yet.
this, I mean, when we first thought of this interactive prompt, it was delete that was the one where we wished that it would just tell us what we're deleting.
Sorry, John, your audio was cutting out there. We missed.
My laptop had a little freeze. Yeah, so on the subject of pool creation, I do have my inadequately publicized work in progress branch that adds the pool set concept and does the higher level creation of pools. And does that by letting the user say what fraction of their cluster they intend this pool to be to get around this sort of first pool versus 10th pool thing. So I'm kind of running behind on that, but yeah, that's kind of the interface we should be exposing to users as a friendlier thing. And more generally, when we've got things like PG nums, let's not invest too much in friendly PG num manipulation compared with just hiding the PG nums from the users, which is the sort of real fix. I'll find a link to my branch.
Yeah. Okay, well, maybe I'll look through the CLI as a user from the user point of view again and see if there's other like killer use cases we could have for an interactive mode. Because it's true that anything involving PGs and this is like there's a better answer.
I think removal could be a good enough motivation in itself for any of the infrastructure we need. I think having interactive stuff in certain places is definitely a good thing. We just need to be constrained.
What are the other yes, I really, really mean it commands that we have?
Enabling experimental features in CephFS.
Okay, well, yeah. Don't really need interactive mode for that.
There's a sync force on the monitors. There's NewFS on MDS NewFS. Deleting a file system.
Probably removing an FS.
Setting file system flags. Because some of those are like experimental sets. Yeah, there are a bunch of places where they're optional. Setting the minimum required compatible client if there is an incompatible client that's currently connected to the cluster.
We better have three completely different use cases before doing this.
Yeah. Experimental cache modes. Anyway, okay.
Yeah, move on. Okay, the next one is really like my super top, one of the top wish list things I have. Ceph OSD crush freeze. The use case for this is that you have there's been something has happened to your cluster and you're in a degraded state or a misplaced state, and it's going to take several days or weeks to fully like rebalance the data. But for reasons, okay, any reasons, maybe you're going on holiday or maybe other reasons, you just want health okay on that cluster again. So what Ceph OSD Crush Freeze would do is it would use something like, I guess it could use upmap to just take like a snapshot of the current upset of OSDs for all PGs, and it would let the ongoing backfilling PGs to finish backfilling, and they would go to active as clean. But all of the other PGs that were in backfill wait or recovery wait, well, not recovery wait, but backfill wait, would just go active clean like immediately. And then so that's the use case. That's the feature. That's the use case. What do you think?
This is a totally different answer than I gave you when we were in Beijing. But having thought about it again the second time, it feels like this is slightly the wrong layer. What you actually want is a data migration or a rebalance, a data migration pause. So you want anything, if there's any degraded PG, you want it to continue to recover to become not degraded, but anything that's misplaced, you don't care. You're just going to leave it where it is, and that's going to be fine. And so it kind of feels like, from a user's perspective, they shouldn't be thinking about that this is Crush doing this, like fixing the mapping or something like that. It should just be like whatever the verb is for describing misplaced data being moved to where it should be, that being paused.
Yeah, it's like to
does that
freeze the
match?
placement, freeze the current placement.
Yeah. So like, I don't know if it's rebalance or it's not really rebalance. It's like migration, or it's whatever the word is, and then freeze on that.
You agree on the use case, but we don't have a good verb for it.
Yeah, and I think it would operate at a slightly different level. It would be like a flag in the OSD map that indicates that we shouldn't try to move PGs that are misplaced. That's basically it. And that because that flag is set, then the PGs would go clean. They would still say misplaced, but the health okay wouldn't. It would be a health okay, I guess. Does that make sense?
As long as all of the things related to like, I mean, I know the mon is going to be like super slim and trim in the very near future, but like all of the things where you're tracking old OSD maps. I mean, you shouldn't be tracking old OSD maps. However, this is done.
Yeah. I think that's
when
right.
You said when you said misplaced, you meant remapped. There's no misplaced PGs.
Yeah.
Right.
Exactly, yeah. Right.
So
I think it's like active remapped clean is actually what we want. And in fact, I thought we made that change in either post mimic or for Luminous, where the PG is clean and can be clean and remapped at the same time.
I believe so.
Which means that the OC maps can trim and we can go. But there's probably like still a health warning that I can't remember. I think that
so you wouldn't use UpMap for this?
No, I don't think so. I think that you would it'd just be a flag that tells the OSD not to like start a new backfill on something in order to migrate a PG. I think actually, I think that the implementation details are sort of somewhat unimportant. I think the key thing that I struggle with is that if you set this flag, then it's basically telling the system to like pause data migration to where it thinks it should go. And if your end goal is to get a health okay, my first impulse would be to make, if you have that flag set, let's call it no rebalance. If you have no rebalance set, then I would want a health warning reminding you that you have that flag set, so you don't forget and the cluster doesn't like never move data. So it almost feels like what you would want is to set the flag and then mute that flag for 48 hours while you go away for the weekend. That one warning. You'd still get all the other warnings for the recoveries that are completing, and then once it's done, then the only warning that remains is that no rebalance flag is set, but it is muted for 48 hours.
So there's already a no rebalance flag.
Yeah,
which does that.
Bad name, but
okay.
Yeah, whatever it is. Does that make sense?
The problem, Dan, though, that we need to not move data because moving data sometimes break things, or is it just that you want it to say health okay, so there isn't pager duty? Because like on a big cluster, maybe rebalancing should just not be a warn, because there's
no. It already. I mean, so it's true. I mean, this is true, and actually, we'll come to that in like one of the next points. That's true. I don't know. I thought of it as a when I thought about it also actually with up maps. Then you would have like a thing that like you could like gradually remove these up maps to get like very gradually to the correct the pure crush placement, And like, so another use case for this freeze thing was to change the tunables of a cluster, to like change from the hammer tunables to the jewel tunables, which actually shuffles everything because it's this choose least stable flag that moves all the data in the cluster. So with this thing, we would be able to set the tunables, and then freeze the placement, but then like super gradually, like maybe over a period of 1 year, phase out the old placement and phase in the new placement. You see what I mean? So it's not that I would want to like freeze it and then like,
Yeah.
that's why I'm not sure the flag actually works.
Yeah.
So an alternative, because we've talked about that mapping change before, and in the past, what I've advocated for is that we sort of maintain both of them and we just do it by the hash. So we like increment one PG at a time to say all the PGs prior to 1.f are mapped the new way, and all the rest are mapped the old way still.
Yeah,
I don't know.
This is more general than just like a crush mapping change. It's any kind of other, like a new OSD addition or other topography change in the cluster. The same sort of situation where you might want to gradually shift to a new placement entirely. And this kind of is a mechanism to do that.
But I mean, all of our other throttles and controls, which aren't there yet but are getting much better, should be dealing with the like impact of doing that migration. So that makes me think that what we really ought to be worried about is the reporting. Or not really ought to be worried about, but that we need to think about those as separate issues.
Yeah, it feels like we have sort of like 4 different goals, and each one can be addressed in at least 2 different ways.
Right.
And it's not clear that, I'm not sure that one is going to be the best way to address all of them. But I mean, having something that like just fills out the up map with every current mapping, so you can like pull them out, seems like it would have a range of use cases, but they're kind of low level. My inclination is to like address the high level goals individually first.
My particular concern with the up map thing is that if that puts the cluster into health okay and there's a dramatic imbalance, then like none of our other, for instance, our like data fullness measures and stuff, none of those are going to work correctly, and that seems incredibly dangerous.
Well, you would have, I mean, so this is then skipping to the next point, right? I mean, you would have up maps, you would have up map labels. So you would have up maps that came from the freezer, and you had up maps that came from the balancer. And like the balancer would keep working, and the balancer would keep, actually maybe the balancer would gradually remove these freeze up maps or something like that. You know, you would have, probably that's what it would do. Yeah. It's very tricky. It's just, you know, this is coming from a kind of like feeling as an operator in those stressful situations where you just like, maybe the monster, it's usually that the monsters are filling up or, you know, something like this. And like the cluster is really in a crisis mode. So maybe if that's fixed, but you know, my feeling is that we're going to have something else. We'll have some other reason. There'll be some other issue in Nautilus or whatever's after M, that will just need something like this. I don't know. I can move on.
Okay, go ahead.
Yeah, so up map labels, I skip it because it's the same thing. The next thing is about health improvements to health. Okay, so the very first one was actually a request from the guy at the British guy from STFC that has the 15 petabytes physics data cluster. They have some kind of hardware issue and they have inconsistent PGs all the time. And basically they were like, it's a bit scary that one inconsistent object leads to health error, and like health error in most people's monitoring systems leads to like pagers going off. So just like a tiny paper cut would be to make some configurable health threshold, configurable threshold on the number of inconsistent objects or PGs to trigger health error, but keep it health warning otherwise. Okay, so that's one minor thing. Any feedback on that?
I'm instinctively uncomfortable with not considering inconsistent data to be an error.
Yeah.
But I do.
Okay,
I understand. So some people run their systems in a way that, like, they're managing at a different level. The life cycle of their known to be unreliable hardware. I wonder if for those people it would be sufficient just to be able to mute the whole alert rather than setting a different threshold on
it.
Maybe. So the related part of this, I think, is the mute, which I guess is that what the pull request was about? There's a whole discussion about this that maybe we should talk about, or maybe we shouldn't. I guess that doesn't quite cover this case, because you'll have one inconsistency, it goes away, and then mute will go away, and then you'll have a new inconsistency, and a new alert will come back, and you have to mute that one too. You'd have to have like
I'm kind of assuming we had a permanent mute.
Yeah, I guess that would work.
What does the pull request do?
Well, the pull request is like very specific for something for muting. The pull request isn't really sufficient. But it triggered this whole conversation about how you would make sort of a robust mute. But I think it comes down to like, because you can't just mute Ceph OC down because you might only have one OC down and then like 5 more fail, but you you want to know about the new those new failures. So it has to be like muting individually identified detail entries, or some like counter, like if there are in. Right, because like you might have degraded object is like at 2%, and so you mute that, and so it'll mute as long as it's less than or equal to 2. But if it jumps to 3, then you'll get a new alert. I think we need to have some both.
It's like a mute. It's like a warning appeared at some epoch, some OSD epoch, or is it an OSD epoch? I'm not sure. No, it's a type at a timestamp.
I think it could be a function of the health detail, where you have the health code, and then you have a bunch of detail entries that have some identifying information in them, either like a scalar value or a unique identifier. And then you can mute either the entire warning in perpetuity, which would be like a very dangerous thing, or you would mute the individual identified detail items. And so if a new inconsistent PG pops up, that isn't muted yet. Or you can mute against a threshold on the scalar value, either like individual details or the sum of them or something like that. Does that make sense? It seems like we could come up with some like relatively constrained set of like ways that you mute that would capture.
You could just do it with a regular expression.
Yeah.
So picture the list of health alerts in a graphical user interface, and picture each one having like 2 buttons next to it, one of which is like ignore this for now, and the other of which is always ignore alerts like these. That's the kind of workflow. And it's true that you could kind of do that with a regex currently, but it needs to be more structured so that we can also report easily to people on what things are currently muted. That piece of information is really important for anyone who's supporting the cluster remotely. They need to know which alerts their user has muted.
I mean, I think so. I would think that, like, I don't know. I mean, I don't know how Ceph health detail would change. Would it still show those? Would it still show the warnings, but write that they're muted in brackets beside or something like that? Like, is it just affecting the input to the health okay?
So you can either. I mean, so I'm thinking of this in terms of like the JSON structure, and you would have the existing health field with the list of things which aren't muted, and then a separate list that has exactly the same syntax, but is all the ones that currently are muted. That way, if a tool consuming it was unaware of muting, then it would still see only the unmuted ones. But you could do it the other way and put a Boolean flag next to each one.
Right.
I think the muting makes a lot of sense. Probably someone just needs to sit down and define what the structure is, and then like the proposal list or whatever. We'll make sure it covers all of our scenarios.
I think the thresholding is a fair bit harder to define because some types of help alert won't have a threshold, and anything that's providing a user interface to this stuff needs to know like what prompts it can present for each health alert. So the mute it once, mute it always is quite uniform and the same for everything. But the prompt that says something like mute unless the number of degraded PGs goes above such and such is maybe harder to expose.
Yeah, I would expect that button when you mute, when the warning says 2.5% degraded, when you mute it, it would just look at the structure of the alert, and it wouldn't be identified by a unique identifier, but it would be identified by a threshold. And so the mute would just automatically be based on that threshold. So the interface wouldn't be any different, but implicitly, if you muted something that was 2.5% and it jumped to 2.6, the mute wouldn't apply anymore.
It's pretty. You'd have to put some like wiggle room on that, because when you have any degraded PG that's accepting writes, the number of degraded objects just increases while that thing's still backfilling.
Yeah.
Yeah.
I'm not saying it's not useful. It's sort of noticeably more complex than the basic muting.
Yeah. Okay.
But if we like, I think it solves 95% of the use cases if you can mute the ones without a parameter, without a threshold.
Yeah. Okay.
Okay. The next thing was about Ceph volume. So this is just general user feedback that Ceph volume is like super cool and super powerful and definitely the way to go. Super reliable. But we really liked, and I guess other users would agree with me. We really like the simplicity of the output from like Ceph disk list. It very clearly shows you what are the SCSI devices on your system and what OSDs are and which dev SD, whatever, which devices are used for journals, how the journals are linked to each other, to the OSDs. So it was like very concise and ultra useful output. So yeah, hopefully maybe I don't know, maybe the default should be less verbose. One thing is that it doesn't show the dev SD device. It just shows the logical volume, in fact. So yeah.
Okay.
And then we thought of a cool, I think Sage, you thought of this. Something useful that could also be used by the orchestration tools would be a batch prepare. So you have like Ceph volume LVM batch prepare me this server that has 24 spinning disks and 4 SSDs, and just do the right thing.
I think we need to do this somewhere. I'm conflicted as far as where to do it. When we're thinking about Ceph volume, it seems like a natural thing to say type Ceph volume, /dev/star or something, and have it just go do it. But then yesterday, I think we were in the container call and we were having a conversation about how the interplay between Rook provisioning devices and the manager or whatever should work. And it feels in the context of that decision that the manager or dashboard or whatever, something is going to like ask you for an inventory of the hosts and all the devices on them, and then is going to go sort of instantiate a bunch of individual disks. It feels like it makes more sense for it to live in the manager in that case, and then call through whatever the generic interface is for talking to the provisioning layer. Because I think the thing to keep in mind is that, well, it's simple to think about the case of an empty server and a bunch of blank disks and doing the right thing. What happens 3 months down the line is that, like, one of those SSDs fails or one of the disks fails, and so you have like an empty slot on an SSD and you have a new blank disk, and you have to like refit that into the context of what used to be there.
Yeah,
what was previously decided to be optimal.
We have that exact thing for Joule with Ceph Disk, a thing that looks at your servers, that looks at your disks and works out the optimal, and then it fills in the holes. It's doable. So when you said that the manager would do it, would that like, how would the manager know on an empty OSD server? Like, do you have like a Ceph inventory agent that's like telling the manager, here's all the servers and here's what's not used on all of them, and then you could click OSD, like.
So this is a really nice setup for the agenda item about the orchestrator interface.
Mm-hmm.
Yeah.
Yes and no. Yeah. Right. So the nice thing about putting it in the manager is that you can access that logic in multiple ways. Like the dashboard could call out to it. The dashboard could like present a GUI that lets you click, or maybe you click a button that says just do the right thing, and it does it. But you can also wire up CLI commands that also trigger the same code in the manager. So it'd be like Ceph space volume space whatever. But yeah, it's more complicated because you suddenly have this added step of the manager calling back out to the provisioning layer, whether it's like raw SSH or Rook or Ceph Ansible or something, to like actually do things. So I don't know. It's pretty fuzzy for me. Maybe John has maybe a better, more specific notions about how this fits together.
Yeah, I kind of had been defaulting to the view of the disk choice stuff living in manager, but there are a couple of cases where that doesn't make sense. The main one is if you're using something like Rook and you're configuring it to say use all the disks on all the hosts with a certain label as OSDs, such that when the hosts are added, it will automatically slurp them up again. If we wanted the manager to be making the disk usage decisions, then it would have to somehow be in the loop in that process, which is not impossible, but it makes the interface a lot more complex. And it's actually a lot easier in terms of the interface between the manager and the various orchestrators if we just have a way of deferring that to the orchestrator and saying, whether you are Ansible, DeepC, or Rook, go do the drives on this host. So the current draft of the interface has the add stateful service call, which is the thing where manager can say, right, that drive, that partition, go do it. And then the add stateful service rule, which is where it defers to the orchestrator and says, do it on every host that has this label. I do want to keep the interface simple, but at the same time, I think this is one area where people are going to want both, because that thing of being able to click in the UI on a particular drive, that needs to exist. But at the same time, the orchestrators that we're using have various levels of opinionated logic built into them already, and they're not going to want to throw that away. But they have to be able to feed back to the manager and say, like, roughly what they would do if you ask them to do something, so that we can still have the workflow where we warn the user about which disks are really going to get formatted if they click the button. But in any of these cases, it only makes sense to have it in Ceph volume if the orchestrators, whichever orchestrator you're using, is then going to use Ceph volume, which is realistic. So we had a discussion in Beijing about whether Ceph volume should be doing the emptiness check on devices so that all of the various orchestrators would have the same definition of what constituted an empty drive. So things like that, that could still make a lot of sense to have it in Ceph volume so that whatever the intervening layer is, it can behave the same way.
Yep.
question for you, John, or for Sage. In a world where we're moving toward having a single OSD on every server, does this change?
You mean an OSD process on each server?
Yeah, managing, something.
I think the devices still stay the same. Like we still need to set up every single device for logical OSDs, and you still need to make a decision about where the journals go and where the other data, like metadata pools, go, etc. So that's another point where we wanted this to be above the Ceph volume layer. We need the extra information about what the use case is for this cluster. Like, do you need metadata pools that are faster for RGW or CephFS? So you have SSDs acting as OSDs, or are you purely going to use those for caching or for journaling?
One of the reasons I bring it up, though, are things like, okay, now if you've got a single OSD process that can start making decisions about how to use storage, say you have an SSD failure, and that's being used for a write-ahead log or something on a bunch of different devices, can you set up policies now where you can utilize capacity on other SSDs that you have to recreate those OSDs without having to actually replace the hardware? And do you want to do that? There's some things that you might be able to start doing if you have a single OSD that's just managing pools of disks, right?
I think trying to plan our orchestration stuff around that is getting too far ahead of ourselves. Among other things, I'm pretty sure we don't want to do that, but we can have the discussion. Just
I'm not sure that making it a single process design changes how that works either. It could be the same regardless.
Well, you really can't do it easily with multiple processes unless you have all of those processes understand all of the hardware on the system, right?
So our eventual changes might enable stuff like this, Mark, but I think that'll be a discussion when we have those changes, not that we should be worrying about right now. I think that if we do, that'll just mean that all of our orchestration tools are running many years ahead of what anything else in the system can actually take advantage of. And that'll slow down other future work.
Yeah, I'm not too worried about it. But I think one of the other, an aside, but one of the other shifts in thinking I had after talking to the DBDK and SBDK folks in Shanghai was, I'm not actually sure that the combining a lot of OSDs in one process makes as much sense as we previously did. That was originally driven by like RDMA connection counts or whatever and multiplexing. But I think actually a more likely endpoint is that we'll actually want to keep these things separate so that we have TCP connections terminating on the same core that's handling the IO for the particular device. So we might actually be pushed a little bit in the other direction where we want to keep them separate. Whether they're in the same process or not is sort of irrelevant at that point.
But the same process is necessary for the DBDK to work efficiently. That's the whole point. Like that's the driving feature in my mind, right? But this is kind of getting
right. Yeah, because it's the same. Right. Never mind. Yeah, same network device.
Yeah, anyway. Let me continue.
Okay, go ahead. You're right.
Sorry, Dan. Do you want to pull us back to somewhere?
Yeah.
I mean, I think so. I think that the verbosity thing, probably you guys agree, but the second half is, the use case is like it's just the use case that we need. We need to do the right thing. Maybe give me 2 or 3 options for my different use cases for my cluster. But we need to do the right thing on a whole server level. I think that's the point. It doesn't have to be. I don't care if it's Ceph volume that does it. I care that there's something that does it.
Did you say that you have one of these for your hardware in Joule right now?
Yeah, totally. Yeah.
Can you share that? My concern is that I don't know if we can do this on a generic basis, but we could maybe start building up like databases for certain kinds of hardware deployments or something.
Yeah, I'll share it right now. I think that I don't think it's changed since this. We might have. I'll repush like tomorrow to make sure that it's the latest, the latest and greatest. Probably we were missing. This might be missing some like minus blue store here and there, but otherwise this is it. I just put it in the chat. Okay, so I can move on. The last two were like, okay, this modular client was something that came up. This is not usability at all, I guess. So I'm kind of also now abusing my time. Suppose different users are implementing like Rados level functionality and they want to share it, but they don't want to support it. We were thinking of maybe there could be a contrib, like a manager module like thing for the client where you enable client functionality on the fly. Like suppose CERN was writing a version 2 of Rados Striper and we wanted to pass it upstream, but we didn't want it to be like, something that everyone uses. I don't know. I don't feel strongly about this, but
what would the difference be between this and just building some extra dynamic libraries that people could either use or not use?
Do you mean and ship those with Ceph, or like not ship them with Ceph?
Or maybe they would live in separate packages or be disabled in CMake by default or something like that.
I think the main thing is it would be nice if there were a framework for doing this, because right now, for instance, we merged in the Striper, but then I forget someone from SUSE did a lot of work to make it an optional compile sort of thing.
Yeah.
And there's not a good way to have stuff that is in the tree but isn't included everywhere, just because they're unified libraries and we've got a unified help text output, and expectations for that help text output in our tests.
Yeah.
And so, yeah, it would be nice if we had a way to sort of make things optional without doing that full touch everything involved in the build process for every one of them.
Yeah, I mean, this is not, I don't know if that needs more discussion. I'm not sure how many beers had been consumed at the point of that came out. Is it okay if I move on?
Yeah, sure. I like this idea. I just don't know how to do it.
Right, exactly. Yeah, I'll also skip the PG hard limit one because that's basically that's a debate that Kifu and I were having. I think too many people have been burned by this PG overdose protection that we should just increase the overdose protection a bit. I'll probably just send a pull request and then let the debate happen there. Guys, the rest of the items are not really usability, but they're kind of like things that came up that would be nice to have. Can I abuse this time to go over them, or do you want to move on to other things in the agenda?
Let's do it. Just go through them really quickly.
Okay. Let me do them in reverse order, okay?
All right.
Because the next one happens to be something that was already discussed and is decided to be a bad idea. CephFS. So for backing up CephFS, it would be really cool if you could easily see the list of files between two snapshots, the files that have changed between two snapshots. So NetApp has this like snapdiff functionality that does exactly this, that feeds into like TSM, for example. I guess all backup systems have this basic functionality. I guess I say the list of files because then the assumption that the backup system will then read those files in their entirety. It would be even better if you could export the diff like we do with block devices and only get like the parts of the files that change, but I assume that that's more complicated. Any thoughts?
Yeah, we've talked about this in the past, and nothing's built in. You could actually script the easy find for change files pretty reasonably, I think, with maybe you can't with the rstats across snapshots. You can across time, but maybe not across snapshots.
At one point, when you would stat and snapshotted inode where the rstats hadn't fully been like collected and assimilated or whatever, it would block. But I'm not sure if that has survived. That was a while ago.
No, I just don't remember if you can get rstats on snapshotted directories that are useful that way. Yeah, so I think you can just look at the rstats on a snapshot directory, and so it won't tell you about individual files, but it lets you identify whether a file is changed across between those, or whether directories change, so you can build a very fast traversal.
Is there nothing internal that can do this more quickly?
Not really. I mean, someone could. We could. I mean,
build it. Yeah.
we could build it into the MDS, but it's the thing that you would be cutting out there is the network round trips between the client and the MDS. It would be doing the same process where it
It's the same.
like
Okay.
traverses the tree and looks to see. We would need to build some kind of like log with a database of diffs otherwise, and I don't know if that's worth it.
There's no, there's no.
but I
Okay, yeah.
suspect
I mean, I
not.
don't know internally. Yeah, I don't know internally how it works, but I guess I imagine that there's like a slice of the file system that you can somehow see, but I guess not.
Yeah, no, it's all split up by the directories. For
Okay.
looking at file diffs, that's not supported in the MDS right now. One thing that has come up, which might have been what Josh was about to talk about, was an easy diff between individual Rados objects. I don't know if you want to talk about that, Josh.
Yeah, I was talking about this a little bit with Jung and Beijing, and he was having a similar opinion to you, Greg and Sage, about having to traverse the whole tree still. And I mentioned to him how the RBD does it by keeping an index of which objects have changed between snapshots with the object map, and something similar might be possible with CephFS directories, I guess. But at least at the Rados level, you can go and get the diff for individual Rados objects, so that can become more efficient.
The way that the MDS is storing the metadata, like once it's loaded in memory, you know exactly which files have changed within just by traversing the in-memory
the issue
structure.
for us is that you need to go and look at a bunch of directories. So it's analogous to wanting to do a snapshot diff across all of the RBDs in the cluster rather than a single RBD.
Yeah.
Once you're at a folder, it's very easy.
It really feels like the rstats on the snapshot of directory inodes is the way to like do that. So I think it's a matter of making sure that actually is correct.
Okay.
I'm building a test.
So we've prepared, like we're trying to hack together a script that does this. So we'll share that when we do. I think the community could use that script as being one of the things that just gets shipped.
Yeah.
Yeah, that sounds great.
We mentioned rsync, like rsync CephFS mode, but like something even more general could also be useful. Okay. The next point was that one of the common use cases when you're for the MDS balancer is that you want to like add a particular. So I had thought of this as like a path prefix balancer. So like everything in like /home, I want to shard across all the active MDSs. But apparently, Sage, you had thought about this. It came up in a different discussion, right?
Yeah, I remember talking about it. I can't remember if we decided that certain solutions did or didn't work, but this feels like something that's analogous to the pinning, where you just also have a little thing that you tag the directory with that says like shard all children, and so as they get instantiated in the cache, we just ship them off to a random. I think if we have that hint, then I think it wouldn't be that challenging to implement, but yeah. I can't remember if there were other issues or not.
So because like, for example, for the Manila use case, this is what we do with scripts anyway. We just shard all the Manila shares across all the active MDSs. And the last point was that, well, I was explaining what we do with our other file systems at CERN, and we have like we use OwnCloud as a sync client, so the users can basically come in and modify files through Fuse through the front door, or call it the back door, or they can use like the sync client a la Dropbox to write the files. Now you can already with these open source Dropbox systems, you can already use, of course, CephFS or CephS3 as the backend storage for these things, but they're used like as the data store. They're not intended for the users to also access the files through that gateway. So that's what's unique about what we do with so-called CERNbox at CERN. Yeah. It's a kind of a cool idea, I think, that we've started discussing internally at CERN. If interesting that we could work on.
I got really excited about this when we talked about it in Shanghai, because this is a use case, the like internal Dropbox that comes up a lot with our enterprise customers.
What restaurant?
Well,
Yep.
no.
Okay, so so we're having a discussion at CERN. We can keep that. We can chat about that more, I guess.
Okay,
I'll mute.
enjoy.
Wait. I think Jan's on the phone. Okay.
Okay, going up to RGW. So there was I think it was it Robin, right?
Mm-hmm.
See that on. Had the idea with Danny that they should be spinning down cold disks, turning off entire servers. With things like OpenStack Nova, we know how to power on and off physical servers via Ironic, so they have all the credentials to talk to the IPMI interface. Yeah, so you could, for example, you could schedule daily times when you power on the servers, sync all of the changes, and then power it down again for a cold storage layer in RGW.
That sounds cool. This sounds like 2 steps past the current RGW tiering stuff.
Okay.
So we're struggling just with the basic tiering.
Okay.
But yeah.
Okay.
Seems
when they mentioned this, then the idea for a tape backend is also cool. Okay, maybe it's also 2 steps ahead, but at CERN we're writing an open source tape management system to replace our old open source tape management system. So I had the idea that maybe we can somehow work together on that part. Again, okay.
Just really briefly, the conversation here, this actually just came up on the list, I think, yesterday about doing tiering in Rados or doing it in CephFS and RGW. I mentioned there, and I'll say it again, I still like the idea of doing it in the CephFS and RGW layers because you have better understanding of what you should tier and when. I think it would be awesome to implement is it NM API or something? I can't remember what the HSM APIs are called. DM API, maybe that's what it is, for the POSIX thing for CephFS to do this. I think would be really cool. And the same thing, we could do the same thing on RGW also. But
okay. Okay. Then moving to the last idea, which was this Mon MGR idea. This was like from left field, crazy idea, probably solving a problem we don't have. Basically, we had this. We thought of embedding the Mon code into every OSD, so that basically you have a subset of the OSDs becoming active Mons, like 3 or 5 of them, and you distribute those active Mons. You select them with the crush map, so you get your Mons running for free across failure domains in the cluster. Maybe this would. Okay, we wrote some pros and cons. Maybe this lets you drop the Mon sync code, but of course the Mon sync code is already like battle tested and really working well and orthogonal to the PG sync code. Yeah, we kind of like the idea of using Crush to distribute services seems kind of cool. Seems kind of useful. You could use it for the Rados gateway as well. Circular dependency, that's nice. Yeah, I don't know.
Yeah, this would be a pretty radical reworking of Ceph, and it's not something you can take on right now. It's not a bad idea for distributed systems, and not just because of the crush stuff, but also because it means that as nodes fail, like we could reproduce them without having to do that. But right now, like the monitors are well-known IPs, and that's part of their functionality is that clients know who to talk to connect to the cluster, and OSCs when they turn on know who to talk to connect to the cluster. And replacing that would be a major undertaking.
The idea of having something automatically like fix up the Mon cluster and move things around is great. I think that thing is going to be Rook or something similar in a Kubernetes environment.
Yeah. Yeah, this was definitely a late night idea. Okay. Yeah, I think that's it. So thanks for giving me this like platform to relive some of the finest moments from Cephalicon. And I hope some of it actually is useful to you guys.
Definitely. Thanks for taking the time. I think probably we should come back to this and sort of scrape the actionable pieces out of this as we're sort of doing our planning for Mimic, because I think there's a lot of good ideas here.
Planning for Nautilus.
Or sorry, Nautilus, yeah. That next one thing. Okay.
Yeah.
Okay.
Awesome. Okay.
Yeah. Thanks so much, Dan. We didn't talk about a hierarchy of managers, right? I think John probably has discussed this before, though. So do you just want to, real quick?
Well, I didn't write any of this in, but I can just give my opinion about it. I think that we could have like a little baby manager that can exist in a hierarchy that just knows how to do certain stat stuff. But if we got to the point where we were thinking about like distributing queries or anything across them, then I think we'd be getting into the territory of stuff that Prometheus should be doing. If people really want to sort of federate stuff that way, then we should move more stuff into Prometheus and, you know, build it that way rather than making the manager sort of overpowered when it comes to distributed data scraping and whatnot.
Right. I didn't even mention it because, I mean, I think that someone needs to have a good use case for 100,000 OSD cluster before we think about doing something like this.
Yep. Cool. Okay.
Right.
Thanks, Dan.
Thank you. Bye, guys.
All right. All right. So there's a whole bunch of stuff on here. We might skip some of these. Well, the next one is you, Josh. PG log memory use. We should probably talk about that one, actually.
Yeah, sure. So I think this will be kind of short because I was looking through so there's two aspects to this. One, probably the more major one is trying to not have an unbounded amount of memory used by PG logs during backfill and recovery. So currently we don't trim the logs during backfill or recovery at all until that recovery is completed, and therefore can build up kind of more and more dirty objects as more writes come in while there's activity in the cluster. And this is all to avoid needing to restart backfill or move from recovery to a new backfill in the case of a failure during this process. But if we run out of memory, that's an even worse scenario than having to do a backfill. So I think we want to avoid that. I think what's slightly less clear is exactly how that limit should be implemented. Can we look at the free memory in the system and have a threshold based on that, or do we just have a simple hard limit number of entries after which we start trimming again? Or what's?
Yeah, I think the simplest thing would just be to have like 20% or 50% or 100% past the limit. We just force trim. That seems like the easiest thing.
Yeah. But considering our limit's now 3,000 per PG, and if you have a fast device,
yeah, it doesn't take long.
So the other aspect to that is maybe for faster devices, we start moving, not keeping all of the PG log entries in memory, but storing them on disk. And
yeah, that actually might be the more useful thing, because once it can be paged out to disk, then like it doesn't really matter practically how long the log is, right? And we could have like at 100,000 or 1 million or something, then we start trimming them, but like mostly we don't care.
Exactly, because the on-disk size is kind of small. But
the other discussion that Radek and I were having this morning, I think we've probably talked about before too, is at what point does log-based recovery stop being as useful? Like how fast do you have to get to not care as much?
Yeah. Because the thing is, like, assuming we did all the work to make it so that we could page out the PG log stuff to disk, it's still going to be a huge pain because during peering you have these missing sets that you're passing around, which is like a summarized, condensed, parsed version of what has happened to just the stuff that's changed and what versions. Like you still need to bring it all to memory for that. It's going to get super. I wonder if what actually we want is, well, short term it seems like just forcing a trim and going to backfill. Yeah. That's a no-brainer.
Right,
but
that's
midterm,
backported too.
Maybe what we want instead is a Bloom filter that says these hash ranges in the PG have been touched. And so when backfill does happen, we can constrain backfill to like a limited range of the object space.
Sage, for the peering or something, can we use something like an interval set so that don't bring everything into memory, but just keep everything on the disk, and we'll just get some of the intervals in core and then just go and process them?
I think in principle that's possible, but it's like huge rewrite of everything, because right now peering gets a complete view, and it would have to be like a staged thing. It would be huge, I think.
Sure, but I think it would solve the whole problem altogether.
Yeah.
And maybe worth spending that sometime and then just do this. I don't know, but
I think the other thing that Mark is getting at, though, is that there's also a large performance cost to the PG log, perhaps.
Yeah.
And so if there's a better way to optimize for recovery for faster devices, maybe we should do that instead of trying to develop a way to keep everything on disk more easily.
And there's a point too, right, where if you're talking about like, you know, 1 million IAPS or something, keeping that big of a log around and, you know, doing all that work to make it so we don't enter. It's just at some point it becomes kind of crazy.
Yeah. In the limit, you have like 100,000 objects and you have 1 million entries in your log, and you're just you're optimizing the wrong dimension, right?
Yeah.
So clearly there's a trade-off. I mean, this is like the Bloom filter to me sounds like it might be the right balance where we can have some sort of not probabilistic but helpful hint so we can prune out some of the work during backfill.
Yeah, I think that sounds like a good idea, and that's relatively cheap to implement as well, and maintain on disk. I think another piece we will probably want to look at sooner rather than later is maybe optimizing more how much data we're recovering. Like for large OMAP objects, for example, that RDW creates. There's already some work going on from some folks from United Stack for partial recovery of regular data from an object. I might want to look at doing that for OMAP objects as well, and potentially even doing backfill, comparing ranges that have changed or to only send the diffs between replicas.
Yeah. Yep. Okay.
Do we have a mechanism for detecting that efficiently in either OMAP or raw data?
Not right now. No.
Okay.
Well, with data, it's keeping track of the extent, like the start and end byte or whatever that has changed in the object.
Well, that's if you've got the log, but not if you're
exactly.
Yeah, during backfill.
Okay. So you do the same thing for regular recovery with OMAP, I think, with a range-based map of what are the clean ranges, and only checking the dirty ones. But for backfill, it would be a trade-off of local disk I/O versus network I/O.
Oh.
Yeah, it's like the rsync problem.
Right.
I mean, with BlueStore and checksums, it's cheaper, right? Because we can ask for those, and that just comes out of the metadata, or is it not?
I don't think RocksDB tells you.
Not for
it doesn't really.
No, not for OMAP. I mean for the actual data.
Oh, yeah, we could look at checksums, but I wouldn't use them necessarily for this. They're meant to detect random bit flips, and not to like detect changes between versions.
Okay.
But in any case, I think the partial recovery is a much bigger piece of work in general. So the short-term step, like you said, was is just a hard limit or beyond which we start trimming again, and then maybe the Bloom filters to kind of constrain things. And
Yep. And the hard limit we can
What
back up
about
to limit.
abstracting the wall mechanism?
Which wall mechanism in Blue Store?
I mean PGLock base recover versus traversing all or partial data stored on disk. Basically, we still need to take care of two completely different kinds of devices. HDDs, which are large but offer low traffic, and contrary, SSDs, which tends to be small but extremely fast. SSDs. I mean also here a PMEM or something like that. I guess this imposes completely different requirements. Maybe having an abstraction would do. Not sure. Just asking.
So I think this was kind of going into the next topic a little bit. An abstraction for the on-disk format of the PG log certainly makes sense. I think that's what we've been discussing a little bit on the mailing list. Is keeping the existing abstraction using OMAP for the hard disk case, but since that's too CPU intensive for like an SSD case, maybe trying to add a different on-disk format there. I think it's much more difficult to make a higher level abstraction for recovery and backfill together because they're kind of entirely separate, well, mostly separate code paths at this point. And it would be quite painful to try to combine them in a way that made sense and still kept things stable. Yeah, the underlying representation, though, I think that makes a lot of sense. Back away.
Josh, you were talking about dupop being a big use case for log-based recovery.
Right.
Can we? Are there any alternatives that work, or do we really absolutely kind of need to do it the way that we're doing it, or does it just make sense to do it the way that we're doing it now?
Well, so I guess the good news about dupops is that we don't need an infinite number of them, and we don't need to. We only need a fixed bound, basically, in terms of how much time we want to be able to replay operations for.
And
the downside is that we still need them, even if we do have, even if we are only using backfill. We still need to write down at least a little bit of data about each app.
What do we have any knowledge of, like, how far back that really needs to go? I mean,
so it depends on how far back you want to be able to handle like network retries, essentially. So probably on the order of seconds, but probably not many minutes in the common case.
I mean, again, there we have the same problem, right? Where depending on how quickly you're performing operations on the network, you need to go back farther.
Yes, that's right. Let's depend on the IO speed again.
Yeah. So kind of again, at some point we get to the point where we can't keep it in memory.
I'm not sure that's true because these actually are much smaller than the log entries themselves. We only need like basically a what is it, like 16 bytes or something per app.
So okay, let's say a million IOPS, 16 bytes times how many seconds do you think we need for something like this, Josh?
Yeah, say like 30 seconds.
Okay, so no, I don't know. It's not that bad, I guess. If I did my math right, like half a gigabyte.
Yeah, that sounds right. So it's not the end of the world memory-wise. But yeah, so I guess the other way would be to somehow rewrite everything to never do anything that's not idempotent.
Right.
Which it doesn't really seem feasible.
Yeah.
Okay. All right. Well, we have short-term steps to take, medium-term things to look at. Anything else we should discuss now?
That was about it. I was looking a little bit at just trying to reduce the PG log entry itself, memory size, but I didn't see a whole lot we could do there.
Yeah. Yeah, I mean, I think moving to a mempool would probably reduce or improve the efficiency a bit of the heap.
It's using a mempool for the log entries in the PG log T now, at least.
Oh, it is. Okay.
Yeah.
Okay. So we did that. Okay.
In the long run, would it make any sense to be able to kind of balance the memory usage here versus caching that we have? Do we want to be able to grow and shrink this?
We've talked about that. I don't know. I can't decide if it's worth the complexity. Like during recovery, we would steal memory from BlueStore and RocksDB in order to keep a longer log to do log-based recovery. I don't know. For now, at least, I lean towards just keeping it simple. And if we did something like a Bloom filter to accelerate RocksDB, then, or the backfill or whatever, then that would then that might cover us partly on the other end. Josh, I wonder if just changing it to a deck actually, if it's right now it's a linked list of PG log entries coming out of a mempool. Changing it to a deck would give you like, maybe it doesn't matter actually, just saving a couple pointers. But anyway, might be a bit faster.
Yeah.
Okay.
There's probably some other small micro optimizations we can make there, but
yeah, not too big a deal. All right, so I had the moving the PG log out of OMAP on here, but it's a huge topic that we've already talked about, and I think we should just talk about that during the perf call tomorrow. We'll skip it.
Sounds good.
Lens, do you want to talk about dashboard 2? Quick update?
Yep, sure. I can give you a quick update. To be honest, I don't know if dashboard was actually a topic of CDM call before, so I don't know where to start, but maybe I just give you a quick update on what happened since we've actually merged and are now part of in the master tree. So the merge happened on the 6th of March, almost a month ago. And well, the dashboard basically is a full replacement for the dashboard that we shipped with Luminous, plus the additional stuff that was added to the original dashboard and that we ported over to dashboard v2 before we basically replaced the dashboard as version 1. In particular, these are things like having RGW details listed. You have a list of the mons. Perf counters were added after Luminous, as far as I recall, as well as the config settings browser, which basically gives you a read-only view of all the various config settings that you can set in a cluster. Not yet a way of changing them, but that's something that is in progress, so to say. The documentation about the dashboard has a more detailed feature list where I also try to summarize in more detail what each page, what kind of information is available. But so far, this basically is just converting the old read-only dashboard into the new architecture with lots of UI improvements, some changes on the back end that don't really are that user visible yet. Since the original milestone merge, we've added support in the backend for managing asynchronous tasks. That's something that we need when we get into managing RBDs or pools, for example, where you basically you trigger a job through the UI, but the cluster will need some time in order to fulfill that request, and you can't have the browser wait until the user gets the request back. So we have a task queue implementation that you can see what kind of jobs are currently being processed. The backend part is already merged. The front end part is nearing completion. Other nice things. That's more for developers, but I find it kind of neat, and this is something that we inherited from Django. Basically, the Python backend provides a RESTful API, but you can also point your web browser to the REST API, and you get the output of the JSON, and you can submit parameters and values through the web browser and submit them as if you were a REST client, which makes development much easier. And it also gives you kind of an automated overview and documentation of all the various REST API calls that are available, since they are browsable. So that's merged. It still needs to be completed with some of the API calls. Right now, we're building up a lot of infrastructure and adding lots of modules and components, especially in the UI, that are needed to fulfill the real management tasks. So you're able to enter values, make changes, creating model dialogues. There are so many small UI components that we're currently building up, which pave the way forward to the more user visible features that you can use to make changes to your cluster. So with the task manager UI I just mentioned, other things that are currently in the pipeline and nearing completion is RBD management, so block devices, creating them, deleting them, snapshotting them. Routers gateway management is close to merged, being able to list all the users, their keys, on all their buckets, creating users and new keys. This is almost done. Ceph pool management is already merged from a backend perspective, so the pool controller is there. Web UI is also in progress, so this will give you a way to create pools through the dashboard. But since the main developer working on the UI part is currently on sick leave, I'm not sure if this is going to meet the Mimic deadline. We'll do our best. Also, the newly merged features relate to making config changes and being able to review, or if I remember correctly, where you recently added some changes on where you can basically snapshot a configuration of a cluster and see a diff of what parameters have changed. These things are also going to be manageable through the UI going forward. Tatiana is working on that. And well, the UI will be capable of being translated into multiple languages. So the infrastructure for that is basically in place on the code base. We are now evaluating how to facilitate or how to leverage the community for adding translations. There are basically two web-based platforms that we're currently looking into. The one is poeditor.com. The other one is Transifex. Both claim they do have free offerings for open source projects. So that's something that we would like to tap into in order to set up a web-based platform where users can contribute translated strings to us for all the languages they require. But for the initial start, we will try to come up with a set of translations on the languages that our development team speaks, and using just the Git commit messages basically to submit those translations as a foundation going forward. That's a really rough overview. I gave a presentation about the current state of the dashboard at Cephalicon last week. The slides are available. If you want to see them, I can send them to you. I hope that the recording will also be available through YouTube at some point. I guess Leonardo is working with the organizers on making that happen. I also created a screencast from 2 or 3 weeks ago that just goes through the features if you want to take a look at the UI and you don't want to set it up and running it yourself. But yeah, that's basically it. I'm open to any questions or feedback or comments at this point.
It's worth mentioning that it works with vStart too. You can just start with a vStart cluster and there's a URL right there that you can go.
Yeah, exactly. That's what I usually do for running small demos and stuff at this point.
Great. Any questions?
So it seems like the front-end bits for the pool, RGW, and user management they're kind of at risk for Mimic. Is that right?
So no, for Mimic, I'm pretty confident that RBD and RGW will make it. Pools is the one that I'm currently concerned about, as well as the Grafana integration, because this one, needs more love at this point. What were the other ones you mentioned?
I think I said auth users, but anyway, you've answered my question. I just wasn't clear on whether it was all the front end stuff that was at risk or just some of it. So.
No. So right now we're just building up the bits and pieces as they are already used. So those features are ready. We're not just creating them into smaller chunks and submitting just the individual UI components that are reusable throughout the UI, and then the features that depend on them. But as I said, the Mimic release window is approaching fast, but it doesn't mean that we may not be able to add more dashboard features with future Mimic releases. I think that's what we agreed on.
Right.
Okay, guess there are no questions, so thanks for your time.
It's probably a good time to jump to John, you're next on the list for the orchestrator Python interface.
Yeah. So I'm not sure how many of the relevant people we have on the call today, but it's probably worth just making everyone aware. The idea of this is to have a common interface between Ceph Manager, primarily the dashboard, and the various different backends that people use for remoting out to their hosts and creating OSDs on them and starting and stopping services, that kind of thing. The three that have been explicitly discussed so far are Ceph Ansible, DeepC, and Rook. So the idea is to find a useful, common set of functionality. We spent a couple of hours talking about this in Beijing. And what it sort of boiled down to was 5 basic operations. One is discovering inventory. So hosts and disks, not all hardware inventory, just enough for showing the user where they can do things like create OSDs and place services. Second is creating stateful services, be they mons or OSDs, where the user can say specifically which disk they want to use. Third is stateless services, so MDSs, RGWs, so on, where the user in general doesn't say where they want to run it, but they might say which host labels are suitable for running it. So we want to bring forward the concept of labeling hosts that lots of underlying orchestrators have, and use that as a way for the user to give us policies about what should run where. The fourth one is querying the status of an existing service. So if you're looking at a file system in the user interface and you want to see where the Kubernetes containers for the MDSs are currently running, then you would be able to load it up via that. And then the fifth one is upgrades, where Ceph itself would be able to say to the orchestrator, here is the version I would like to be running. So there's a little bit of a chicken and egg thing there. The idea is that the orchestrator is always something that's running externally to the manager. So it's the thing that drives updates, but the user would still like to have access to that through the user interface. So there's a call for the orchestrator to publish a list of versions that can be installed, and then a call for the for Ceph Manager to request itself to be upgraded to a particular version. The analogy is that Ceph Manager sort of gets put to sleep, and when it wakes up, it'll be a new version. The details of that might be kind of interesting to implement. But that's where we are at the moment. So there's a little bit more detail in that .py, orchestrator.py interface file. But at a high level, that's the sort of level of detail that it's being proposed to expose between the orchestrators and the dashboard. And if we want to access any of this stuff from command line, then we can equally do so. I just think the dashboard's probably going to be the primary user. I'm not sure, have we got Blaine or Sebastian on the call? Or Travis?
I don't think so.
I think not. Okay.
No.
Anybody else have any thoughts about this? If not, then I'll go and eat my dinner.
There's a topic that we were discussing earlier with the Ceph volume interaction and this idea of doing multiple devices at once.
Right. So my thinking on this is that the add stateful service operation that lets you target a specific disk should be sufficient for building whatever we want if we want to build intelligence up at the Ceph manager layer, because it can see all the disks and then do things to them individually. But from talking to the people who've been involved in the various orchestrator projects, that I think there is a sort of a feeling that people would like to keep some of the stuff that's implemented at that layer. And it also, I think, saves us a little bit from having to have such a rich interface. If we can say, for example, that if the orchestrator wants to do the disk auto selection, if it wants to query like some really nitty-gritty low-level piece of hardware information to make its decision, or like look at service tags on a server because they're building an appliance or something like that, then we can say, okay, fine, you guys do that, rather than having to have sort of an ever more complex interface between Ceph and the orchestrator.
I think that the examples that come to mind are setting up DM cache or VDO or Bcache or something like that, where you're setting up weird LVs underneath.
Oh, right, yeah. So that is why the stateful service spec object has an attribute called extended. So the thought is that anything like that is kind of a per orchestrator thing. We can't necessarily assume that every orchestrator knows how to do every one. So in order to present that in a user interface, it might mean that the dashboard needs a little bit of per orchestrator knowledge to know what the valid extended options are for each orchestrator. But yeah, I am sort of, I guess, sidestepping trying to define things like that by saying that they should just be extended options during creation. I'm not sure we can see far enough ahead to define that stuff.
Yeah.
Also, I think the idea of having an easy way to upgrade the cluster from one version to next is one of the steps that should be following at a later point in time, because really depending on what kind of orchestration tool you use, they may not even know about a next version yet or how to access it, because they depend on the package management and the repositories they are subscribed to. So having a generic interface for that's the one part where I'm a bit concerned or wondering how this could be done. But maybe we should start with the node management part first and see how that goes.
Yeah, it depends. As you say, there's a whole sort of chain through which updated versions of software come in practice. I'm a little bit biased by thinking of the Kubernetes case, where it's relatively simple for there to be multiple versions of a container image installed on the system. So it's relatively easy for them to say, there are these 3 different Ceph containers. Which one would you like to use?
That's a luxury that Ansible or Salt really don't have.
Yeah, I mean, if you're inside, Red Hat Satellite or whatever the equivalent is in other distributions, then that becomes much less possible. But I would sort of be inclined to send that back up the chain as a challenge to the people who build that type of infrastructure for the various distros, to say, look, if I can't programmatically discover when there's an update available for my system, then maybe you should give me an interface for that. But that might take some time.
Oh, well, are we talking about update or upgrade? So is it just about having a new minor dot release of Ceph that would be available through already subscribed update channels, or is it really about moving, let's say, from Mimic to Nautilus?
Either or both. And the major updates are where you need more logic in the orchestrator, obviously, to upgrade things in the right order. But I think users still would like some level of manual control over when to do minor bug fix updates as well.
Yeah.
So I guess just finally, next steps. At some point, I'm enthusiastic about doing a draft implementation of this interface on top of Rook. Whether that's me or somebody else working on that. But yeah, I think it's going to be a little bit of a race to see which person who is enthusiastic about a particular backend gets there first and shapes the interface around their particular backend.
Yep.
Cool. Okay. Anything else on that topic? All right. Last couple topics, I guess, are just one really. This came from a subject that Greg brought up in the leader call this morning about building a large-scale set of topology tests where we dedicate some amount of time per month and we run large-scale tests. Can I talk about it, Greg?
Sure. Sorry, I wasn't prepared. This was actually something that Arit discussed in our Supplicon QA thing, which was that it's difficult to run tests that require large numbers of machines and long running times in the lab right now, just because it goes into the queue of things that are trying to lock machines, and if you're trying to lock more than 2 or 3 machines, you never win. So we discussed like reserving lab time for doing that. Her particular example was bucket charting tests that actually have for RGW, which actually have a lot of entries in them, which just take a long time to generate. I think we had some other ideas in the call this morning, but I don't remember what they were. I didn't mark them. Joss or Sage, do you remember?
Yeah, I guess one idea was larger scale performance testing. Nia's been working on a small scale performance test suite that's kind of in its infancy now. We don't yet have the way to view the results or visualize in the cross runs yet, but that's something that we want to have. And getting that kind of data on a larger scale cluster that's filled up over the course of several days, so it's more realistic, is also important. So dedicating some amount of time, maybe a few days a month or every few months, to larger scale testing, I think with both correctness and performance makes a lot of sense.
Yeah. So we sort of need to both have tests before we do this, which means we need to figure out what kinds of tests we want to run. So if you have ideas, we'd love to know them.
Is Mythology the right system to use for that kind of testing? I'm kind of, I think we need to maybe to take a step back and
yeah, that was a question I had.
Don't have tests reason for it, right? So if we are to do it, maybe we should consider what's
Yeah,
the framework we should use to do it.
that was
Also,
a, that was
what
a
kind of
serious
things
question
are
I
you
had.
thinking that we couldn't do?
It's not about what we can or what we cannot do. Is it the right tool? Because
So what is difficult to make it do? That would be easier with something else.
I don't know, like create a billion objects in a bucket, right? It's not gonna work.
Why not?
You don't have the resources on the on the machines there, or you'll take the entire. You need to have a huge cluster that you don't have there, right?
Yeah, so it's a scheduling problem, which might be nice to have a scheduler for, so we could run this more reliably. But that's why we're saying we think we want to shut down the normal queues and just run these larger tests for a couple days out of the month. So the big issue that I've noticed that we've identified is that we don't have any good like databasing or analysis solutions, and that's something that Toothology is going to need to grow. But we haven't really found, or no one's really aware of any other tools that do what we need. Like we still want the way that Toothology controls daemons, the way that it can lock machines and do installs and stuff. It just doesn't seem like we gain anything by going elsewhere. We just need to do a little more integration.
Well, Toothology is very useful for doing, a clean room. You create a new cluster and just dump stuff on it and test it, and you got a result immediately. But these sound like more of aging tests that would need to run and.
Yeah, I think it's specifically this isn't aging tests, right? This isn't a long-running cluster because we can't afford to have the cluster dedicated to storing data over long periods of time. So this is always going to be constrained to data sets that we can generate and tests that we can run over a short period. It feels to me like that the sort of the key thing is whether it's something that we can categorize as pass-fail. Right. So if what we're testing is like how well recovery, performance isolation between clients and recovery handle, and what is the like sort of qualitative behavior of the cluster under stressful conditions, like those are things that are very hard to programmatically define, and then like you have to set like certain thresholds. And I know that the performance test suite has like made a lot of progress there, but I think we should initially at least shy away from those types of tests and focus just on things that we can like validate larger scale correctness.
Yeah, I agree.
I think you need to be really careful about how you set up your lab, right? I mean, right now, Toothology is in this big, huge, noisy environment where lots and lots of stuff is going on, and it wasn't really designed to run performance tests, right? I mean, none of it was. It was, designed to do functional tests, which are very different. I think that if you want this to actually work well, you need to really think about reducing noise and reducing external influences on things, which is not really just a Toothology problem. It's a kind of entire system design problem.
Yeah, so I mean, I agree. I think we should probably focus on the correctness aspect of this first, because that's a much simpler problem.
Yeah. Yeah, and I mean, like some of this, some of the performance stuff can sort of be correctness, but a lot of it is just like, okay, no, we need to make sure that if you have 1,000 shard RGW bucket with 100,000 entries per, then it actually like functions when you do that, because we really don't have any way of making sure that doesn't break. We need to make sure that when we fill Blue Store to 95 to 90%, that it still allocates data and that it happens across large numbers of OSDs.
Yeah. If you remember, I think we had a discussion and we said, okay, we want to actually kind of get something like a snapshotting kind of thing, right? So you would actually fill the cluster up to 60% or 70%, and then you snapshot it at that point, and then from there onwards, you just do different tests and then roll back to the snapshot. I mean, we don't really come up with a good solution there. We thought of actually having an LVM snapshot at each OSD. We just do Ceph freeze kind of thing, and then you take a snapshot at that point. I mean, we were thinking about it that time, and then but yeah, we did not.
This would let us generate some aging.
Right. Yeah. So the initial.
It's just we need a storage space for that too. Given that we want it to run at a significant fraction of our lab might be a problem.
No, I mean, so what I mean is we can actually dedicate a smaller cluster or a small to medium kind of thing to carry out these kind of tests. And then you can actually take, I mean, if we have the provision to take a snapshot kind of thing, I mean, if we can come up with something like that, so you can always roll back and then rerun a different config on the same suite or on the same cluster, and then we can see whether it really breaks or handles all those conditions.
So I have a couple of things that I want to mention here that so we are trying to address two problems here. One is correctness and one is the scaling and how the cluster behaves with time. The framework that we build for one can be used for the other. I feel it's just the resources that we allocate for each of them that will be different. So to address the first issue, what we have currently and what we started out doing is, in my opinion, the right approach, because we have now come up with a basic suite where we have like fixed set of workloads and we are just running this suite on the master branch and only on Smithy machines. So it's a very narrow bandwidth now that we are going to focus on. And this will allow us in maybe a month's time or so to at least figure out reasonable baselines for the correctness aspect. But yes, for the scale and the performance scale and the other things, we need to figure out first the resources and how we want to deploy those clusters. And that definitely needs the database aspect and a right way to store the results, I think.
One thing I want to add in here too is that it's really easy to look at performance numbers and draw inaccurate conclusions about what's going on. We really want to be focused on behavior. What is the OSD doing when we run this test, and has it changed? Not has the performance improved or gone down, because there's too many things to account for there. But if we can say we're spending a lot of time in this function or spending a lot of time in this other function and it's changed because of some reason, I think that's much more useful to us than saying, you know, the IAPS varied by 10%.
Yeah, I mean, to get that point, Mark, so I will not count this as a performance test when we are doing something at 60% or 70% of the load. Mostly I would actually want to measure the correctness, and it is still durable kind of thing for me, right? I mean, it will not break anything. More than performance, I would be more cautious about, okay, whether it can really fill it up to 90% and can still serve my IOs, or something happens at that point of time. Will it really get busy in doing some background work to maybe reclaim space, or once it gets fragmented, whether it can do a huge allocation or not, something like that.
Yeah, there's a lot of stuff that sort of ties into performance, but that we can measure much more directly as pass-fail criteria. Like for instance, this would let us look more realistically at what memory usage actually happens. We can just like get a top-level RSS for each OSD in these scenarios and see if it changes over time, and if we don't understand it, then we know that we have a problem.
I mean,
or maybe those numbers are much larger or smaller than we think they are.
Yeah, I would actually put this as a use methodology kind of thing. So what is my utilization at that point of time? Or will I saturate all my resources or not? And what would be my efficiency if I wanted to really measure at that scale or maybe loaded cluster kind of thing? I would not really look at a performance angle to it.
It kind of seems like the place to start is just to like create the suite and just add one test, and then.
Yeah, I mean, I think
we can add to it, right?
Yeah, we mostly just want to make sure that we like have enough. Like, sure, we can do one and shut it down for however long that one takes to run if it's going to actually use it. But we want to make sure that it's got enough stuff that we actually run it reliably on some sort of basis. And once we're going to do that, like, we probably don't need to use up all 190 machines or whatever on one test, probably we can carve it up into thirds or whatever.
Yeah.
And so it'd be good to have three tests.
Yeah.
But anyway, that's a discussion that's happening that people should be aware of. If you have ideas, please talk about it. I think one of the Cephalon QA emails I started covered that. So go on Ceph and talk about it there.
Sounds good.
Love to hear your input.
Cool. All right. I think that's it on the agenda. Oh no, there's one last item. I don't know what that squealing is. I don't know if you're listening. There's something else that another thing that Greg brought up, and I think we talked about this a little bit on the mailing list. I guess it's sort of a couple related issues. When we build packages for test, we only build a handful of distros. I think it's just CentOS and Xenial right now, although that'll probably change shortly. But when we do releases, we build for like 5 or 6 different distros and a couple different architectures. We currently don't have two things. Like, so we don't have a check after we build the packages for release that they've been successfully published to the repo, and the repos are like valid and usable, and you can actually you're not getting an error, and that Debian 8 isn't missing again. That's one. And the other thing is that we don't have a way currently to say for this random test branch that maybe is as like the release candidate or something, build all the packages so I can run a test suite that just installs them probably on VMs or whatever bare metal machines with that particular OS, just to make sure that they work to run like basic upgrade tests that make sure that the package dependencies aren't broken or whatever it is. We used to kind of do that with the Ceph deploy suite because it would iterate over all this distros defined in the supported directory. But the Ceph deploy testing stuff has gone stale. I think Ansible is probably a better choice for that. But at some level, it feels like we need sort of those two things: being able to build all targets first, and just make sure they all build in sort of the Shaman, the test environment, and that we can install them and that they all look good. And then also like a final check for releases to make sure that they're useful. So might not be much of a discussion item. I think it's probably most people would agree that those are good things. Is that missing anything?
So does that mean we need to have like some extra support to be able to install release builds before they're released?
It probably. I don't really know how the package repo publishing process works, if there's where the staging goes, and all I know is that they're really big. They take a long time to copy, but it seems like in an ideal world, you would go through you do all the test builds, you run all the testing process like we normally do, and then you get to the point where you like build the actual release, you'd build the final packages, you'd sign them, and then you would like stage them somewhere, and then you would rerun some set of tests to make sure that the final bits are actually like good before you publish them and let some user trip over some issue. So eventually it seems like we should be at that point. Or not, we just let the downstream distros do all that. But I kind of feel like we should.
I'm also kind of curious, have we seen any issues other than the packages simply not being there? Have you ever seen like actual dependency problems or that kind of bug?
We do hit bugs in package dependencies during upgrade. Like pretty much every time we shuffle the packages around, we break it. And the upgrade suite catches that, but we only do that on the distros that we do. So that's only on CentOS and on Ubuntu. So if the package names or versions are different on Debian, then you wouldn't have noticed. So I'm not sure if we've hit one of those yet.
But it's a possibility.
But it's certainly a possibility, yeah.
Yeah. And I think it's not usually the packages aren't there, but that they're not signed or something, like some step got missed. So just a basic install would catch all of that, but
yeah,
it needs to be a thing that can happen without being another giant set of work for the people walking down the release checklist.
Yeah. Yeah, it's way more stressful than you get the email the next day that some package is missing, and you're like, I'm gonna have to go deal with it. Than if you just knew ahead of time.
Yeah.
All right. Well, our release friends aren't here, so it's probably not the best time to have a discussion. But all right, I guess that's it. Anything else we should discuss, or should we wrap? I think we're over time anyway. All right. Thank you, everyone.
Thanks, everybody. Good discussion this month.
Yeah.
Yeah.
This was a long one. We should invite them to join us more frequently.
Yeah. All right. Take care, everyone.
Later.
Thank you.